Hi, good morning, everyone, or good afternoon, Copenhagen. My name is Jim. I'm going to be your speaker today. We're going to talk about the history of application security and learn some things along the way. It's a tough time right now. You got death over all of our shoulders, my family and my world too. You got like things like simple as toilet paper hard to find right now. I need this. I'm gonna keep that. We got this kind of looking at, it's tough times. But you know what? That doesn't stop the need for secure software. Software runs the world more than ever before. A lot of us are depending on online services to like keep our job running and to keep connected to our family. And with the need to stay at home around the world, the criticality of online services to keep society running is even more important. And I imagine if you're like me, you're a little bit stressed out. You're watching the news. You're seeing like problems with sickness rise across the world. Shakespeare wrote some of his greatest works while he was in quarantine. So this chance before us, this time that we all have at home, you can use that time. You can waste it, or you can use it to do something creative or something scientific to increase your ability as an engineer. And that's what I advise. I advise like stay working, keep working, keep studying, keep your mind occupied during this time. What a great time to study application security. And so I want to give you a history. This talk is a keynote flavored talk. This is a talk I usually give to start a conference or similar, but I want to use it as as a situation where we can learn a little bit about application security along the way. So let's do this. Let's talk. This is not just the abridged. This is the extremely abridged history of application security. My dates are close. This is not perfect, but the point I'm trying to make is that even though we have these big problems with computer security around the world, things are getting a lot better. And that's the argument of this talk. My name is Jim Manico. This is an earlier bearded version of me from times past. I'm a former member of the OWASP Foundation. I've been writing software, mostly web software, for over 20 years. I wrote a book on secure software for the Java community. Java is basically a bad version of C#. C# is basically Java but fixed. Anyways, I joke. I invest in a lot of security companies, and I live in I live in Hawaii, I live in Virginia, and a lot of hotels when I'm allowed to travel. So let's redact some stuff. Redacted, yeah, whatever. All right. So let's go back to the beginning of history of application security. So I guess the question I'd ask you if you were here is, when did the modern information security era start? That's what we want to figure out. And my understanding of information security history is mostly United States centric. And there's a history around of information security. It popped up around the world really in a hidden way. A lot of the early information security work was done in intelligence agencies and was done in secret. In the United States, our government started a task force in 1967 to study information security. This is a real famous report, R609. It was declassified and published to the public in 1970. And lots happened in information security before 1970, but this is where things got real. This is 1970 when this report R609 was published. This is when information security went from being a hobby or a secondary topic to having its own, to really the birth of itself as its own modern topic to study as a scientist. This is where we really begin to invest in security around the world. And guess what that report said? Pooh is messed up. What they're saying is that all across government and military, that security, information, computer security is horrible everywhere, and we have a lot of work to do. And this is important because now it's an official, well-funded government report by very reputable scientists telling the government and the world at large, things are really bad when it comes to computer security. And so, oh yeah, I'm sorry, it was published to the government in 1970 and declassified to the world in 75. My mistake. So let's look at security testing as a history. You know, when I look at computer scanning products and other kinds of tools that I use to scan my application for security, this is the main way we do security in software. Again, we run a series of scanners: static analysis, looking at the code; dynamic analysis, prodding and testing the live running application; and third-party library security to make sure our third-party libraries are up to date. Those are the three main kinds of scanners that we use in the world of application security. And where did that all start? The first real security testing tool, the first penetration testing tool, was in 1938, called the bomb. Anybody know what the bomb is? This is World War II. This is England and using research from around the world. This is England being able to crack crypto of Enigma. And the machine that they built was big. It's like wood and nails and metal. It's a big physical machine that they crank in order to, a big electrical machine that they would build to crack crypto. This is the first like real scanning tool ever. And it was used to keep, is used to help the Allies win the Second World War. Yeah, it's, Germans running around. You know how that goes. So 1972, this is the Anderson report. This is this is a similar kind of report that we see. Another example of a modern report in the early 1970s where we're first doing real security threat modeling and analysis for the government. 1974, the Air Force starts doing early security testing. 1979, we see Lint, the first code scanning tool. This is great. Lint you point it at code, early code at that time, and it will look through the code looking for obvious security bugs. First of its kind in 79. 1995, Satan comes out. It's a Windows tool that anyone can use. Point, click, scan. One of the first major security scanning tools for operating systems that anyone can use pretty easily. SQL injection, which we talked about in class the last couple of days, was first discussed in 1998. And this is where Nessus, another operating system level scanner, comes out. And now the modern web security era shows up. Crosssite scripting is first named as a term. OWASP WebGoat shows up so security testers can test their ability. Metasploit comes out in 2003 to test infrastructure. 2006, we see SQL Map and other OWASP tools. And then boom. And then we see things like dependency check, the beginning of the DevOps era, OWASP Zap in the last 10 years. And now we have real modern turnkey scanning for the world of testing your application for security. Look at how much progress we made just in the last couple of years. So the point is, we start in 1938 with hammer and nail, building a big machine to crack really weak crypto of the era, where today we have modern automated tooling that every developer should be using while they're working on their software. And so if we look at 2020, we have all these modern things showing up now, right? We have security testing as part of GitHub for third-party library scanning. SAS, DAS, third-party scanning tools, these are very mature at this point and very usable in a continuous integration kind of world. Pen testing is still expensive. There's not enough pros out there. And when compliance and laws around the world are forcing us to do security testing, but now in 2020, if you're not doing static analysis and dynamic analysis continuously every day, we have the tools available. I think it's negligence at this point because it's there for us. It's mature, and we've come a long way. To get here. How often should you be using HTTPS in your applications? That's the question for this next section. How often should you be using HTTPS in your applications today? What's the right answer to that question? The right answer is every app. There's never a good excuse to use HTTP. Everything that you do in your work, everything should be HTTPS. Absolutely. 94. This is where one of the Netscape engineers who specializes in crypto releases and creates the initial version of HTTPS. There's everything wrong with this protocol back in the day. We've seen a lot of mistakes that we fixed since then. And it was and the whole idea of the certificate authority system, which is used to back up HTTPS, is a hand wave. It was not well thought out. 1999, we see TLS 1.0 released, a more mature version of the cipher underneath HTTPS. And in 2006 and 2008, we see the newer versions of TLS 1.1 and 1.2 released. In fact, hey, let's fix this slide. It's okay. You're like, are you fixing a slide in the middle of your talk? Yes, I am. This is a moment of shared creation together. It's an exciting moment. It really is. Trust me. There we go. So in 2008, this is an important time. This is when TLS 1.2 comes out. This is the version of TLS that you should be using today in 2020. TLS 1.0 and 1.1, they're both kind of deprecated. TLS 1.2 and 1.3 is what you should be using today. First designed in 2008. So you can see how long it takes the design of good transport security and where it's actually released to the wild and used everywhere, the time that takes to happen. Now, I'm a little sick, sorry about that. So the question is, when did HTTPS really enter the modern era? That's a good question. And my answer to that is 2009. This is where Firesheep gets released. Anyone heard of Firesheep? Firesheep is awesome. It's a plugin that you can add to Firefox back in the day and just run this application in Firefox. And if you're on a wireless network, as other users hit the wireless network with unencrypted applications, HTTP, their session will appear. You click and you can hijack their session to Gmail, to Facebook. Because back in 2009, these sites would log you in over HTTPS, but then drop back to HTTP, which means your session data were in clear text as you're using every app. Firesheep exposed this problem and made it trivial to do session hijacking over HTTP on a shared wireless network. And that forced Gmail and Google and Facebook and all the major players to move to a complete 100% HTTPS model. And now we see forward secrecy in modern ciphers. We see TLS 1.2 go live in 2013. The Let's Encrypt authority shows up in 2016, by 2015, and by 2016, half the web is HTTPS. Certificate authority authorization is now mandatory, and Let's Encrypt offers wildcard certs, and TLS 1.3 is now published, and TLS 1.3 is a great piece of work. It's simpler. They removed the complexity and had a large community of good cryptographers build TLS 1.3, by far the best version of this protocol. So we start in 1994, where one engineer from Netscape builds HTTPS with a hand wave, not thinking about his decisions very well. Is an author, not his fault. Where we go to 2018, over 20 years later, and almost 30 years later, and now we see a really well-written version of TLS becoming standard in the browser. We see a free authority offering wildcard certs and all these other security enhancements to HTTPS that are available for you today. We've come a long way. Things have gotten a lot better in a short amount of time. And so if you take a look at the transparency report from Google, they're showing today 90% or more of the web is HTTPS. Look at how far we've come. Cheers. Let's have some coffee. And here's my site. Well, I don't know why I put this. This is like an arrogant slide. I'm sorry. So, I have a marketing website. A lot of people, when I'm teaching class, will look at it. Hey, is Jim actually doing it right? So this is a great tool, SSL Labs, that you can use to evaluate if your own website is being configured properly. That's what I'm saying. So let's talk about passwords now. Let's talk about passwords. Let's go back a step. How are we doing on time? We're at 7:45. We're about a third of the way into our talk. That's great. Let's talk about passwords. And so the real first major time sharing system that used a password was MIT's CTSS system. And this is like a timeshare system that students would use and professors use at MIT to do homework assignments and similar research. So this operating system had a bug. It was a message of the day. Do you remember message of the days? Like when you log into some shared system, there'll be a message of the day that administrator could set up. And you'll see this message of the day at login time. Well, this operating system had a bug where the password of all users would be shown in the message of the day on rotation. So you log in, log out, log in, log out a couple times. And eventually, as you rotate through all the message of the days, you'll get someone's password. This is a bad bug. This is a really bad bug when the passwords are I ask, how did you write that bug? This is great. I think it was like on purpose. So if you forget your password, just log in a couple times and the message of the day will leak your password. So that's where we start, where everybody logging in can see everybody else's password at login time. This is not a good beginning to password security. So in 1970, and what we're going to talk about now is how do you protect a password in a database? How do you protect a password in an operating system? Well, Crypt3 is using old M209 code from World War II. And this is the algorithm that was used in Unix up to the 6th edition. This is crap, but this is where we started. Relatively weak password storage algorithm. In 1978, Crypt3 was updated to DES. It's not a great algorithm to store a password, but it's showing the primitives of what a good password storage algorithm would look like. You need stretching, you need some salting, and a good password policy, at least, to have a good password storage algorithm. In 1980s is kind of like an empty era for security. Not much happened there, but we now limit access to the password file to a root user only. In 1991, we see MD5-based password storage with hashing and hashing and salting. That should be a 128-bit salt value. 1994, now we have MD5-based Crypt3 with 1,000 iterations and larger salts. So this can handle 2 to the 48 number of users, getting significant in salt size now. 1995, SHA-1 comes out, and we see bcrypt released in 1999. So here we are in 2020, 21 years later, and bcrypt is still one of the good algorithms for password storage because it has salting and it has a work factor to slow down the operation of this algorithm. By the time we get to 2007, we see PHP using bcrypt by default. And PHP is the most popular language to drive the web, even though it's awful. Sorry. And but PHP has a lot of really good defaults built in for password security. It's defaulting to bcrypt by using the password storage algorithm. That's great. scrypt comes out in 2009. Argon 2 comes out in 2015. And now we're looking at the 3 algorithms that I would advise to use today. bcrypt, scrypt, or Argon 2 are the only good algorithms for password storage. It's beautiful. And so in 2016, Dr. Akue from Dropbox publishes an article on how Dropbox does password storage. And that's the advice I give today. That's a real seminal article describing in detail what a programmer should do to protect passwords of their users in a rigorous way. So where do we start here? We started with MIT's message of the day bug leaking everyone's password to today, where we see an actual professor / architect from one of the world's biggest file sharing companies publishing for everybody how to do password storage correct using bcrypt, scrypt, or Argon 2. We've come a long way in a short period of time. So this is the article, How Dropbox Securely Stores Your Passwords. Everybody should read this. And not just because of Dropbox, it's because this is the advice. This is the first publication of really how to do this stuff right. Pre-hashing, bcrypt, work factor, similar. This is what you want to be reading. And now that we're in 2020, the latest, most modern algorithm for password storage, Argon 2, It's supported everywhere. Most languages have Argon to support. It's the best we got. And where do we start? We started with, message of the day bug to rigorous crypto to store your password. We've come a long way. One of the things I've done as a professional volunteering my time, as a developer, I highly recommend you donate some of your time to the open source world, something. I recommend. It's good for the soul, good for the community. And so I participate in OWASP. And OWASP is a web security foundation. It's the Open Web Application Security Project. It's an interesting foundation for software developers to keep an eye on. It was founded in 2001. In 2002, the first developer's guide was released, a free book on how to write secure applications. In 2006, some projects came out like AASP. These are libraries to help do secure application development. By 2008, we start work on the ASVS, a standard to do a standard of requirements for secure software. 2009, all the cheat sheet project first comes out on cross-site scripting prevention. And then we have that decade, a series of powerful projects like the dependency check, like Security Shepherd for testing, the Juice Shot for testing, and all these modern projects start to show up that are free, that really help testers and developers do application security. And now today, the cheat sheet series, this is what I work on. It's an encyclopedia of secure coding knowledge. Now we've moved to GitHub. There's 50 plus cheat sheets. There's hundreds of people working on them. And we have a living encyclopedia of really detailed information on secure coding that's being worked on every day. And so we've come a long way in building tools and information that will help you write secure code. And these flagship projects, OWASP App, that's a dynamic scanner. Dependency check, that's a third-party library scanner. And each of those tools would cost like a salary to purchase for an enterprise. And we have free versions of them that are very legitimate that you can use to get your work done. I'm really proud of what OWASP has done. I'm proud of the nonprofit nature of it and the free access to these tools. It's a great way to start in application security. One of my favorite topics is to talk about cross-site scripting. In 1999, the term was first described. And in 2002, Microsoft added support for the HTTP only flag for IE6. And this is important because it stops JavaScript from reading your cookie. It's one of the earlier defenses in the standard world to stop cross-site scripting. In 2005, a hacker known as Sami Kamkar attacks MySpace successfully and causes the entire global MySpace cluster to blue screen, shutting down the whole service for several days. Brilliant hacker. And it really demonstrated that you can do worms through JavaScript. This really alerted the world that web security was a problem, and it began the modern web security era. We see Emmett Klein publish XSS information that year on DOM XSS. The Reform project starts that year, the first encoding library I know of. 2009, the XSS prevention cheat sheet was first written. And then we have all these major tools and standards show up in the next decade. The things I look at are in 2012, we have Content Security Policy 1.1. 2014, we see DOM Purify released, a really critical tool to do HTML sanitizing in your web pages. In 2015, the modern version of Content Security shows up with features that make it much easier to deploy. So we start with 1999, Microsoft engineers coining the term cross-site scripting with no good way to fix it. And in 2015 and 2019, we have really rigorous standards that developers and framework authors can use to eliminate this risk. And now we're at trusted types. This is brilliant. This lets you literally program the browser to disable certain JavaScript functions unless you configure them with certain defenses. This is a brilliant standard. As a developer, you might not be using trusted types. As a developer, you'll probably use a framework that uses it. So this benefit will be invisible to your world for the most part. So in 2020, we see things like auto escaping templates is the norm. Content security policy with this tech CSP3 with strict dynamic, way easier to deploy. And trusted types is becoming integrated into frameworks to stop this risk called DOM XSS. Things have not just gotten better, they've gotten a lot better when it comes to this topic. I'm a little bit sick. All right, I'm a little sick. All right, we're good. We're good. Can't be afraid of sickness. Can't be afraid of sickness. All right, let's move on. So a few more dates in AppSec history, just across the whole industry. These are some things that are really, really exciting. I'm gonna jump ahead. Yeah, I'm gonna jump ahead. Here we go. We look at OWASP today. Let me finish up here. When we look at OWASP today, this is like a nonprofit on web security. We have chapters that meet on a regular basis all over the world, from Hawaii to every major state in every state in the U.S., all across Europe. So this is a global nonprofit of developers and security professionals learning how to do application security excellence in some way. I'm not sure if anybody is here, but I usually reserve this if you have any questions. If you have, I only see a few participants, but if you have questions, actually, let me jump to the join at Slido. I'm not sure where I can grab questions. Let me see. I'm going to go hit my question page. Where is that? Hey, I'm going to stop. Hey, do I have hello, everybody. That's about the end of my talk anyways. If you have any questions, let me know. I really appreciate you being here at NDC and supporting NDC. NDC spends a lot of resources to get their conferences running. This is a big hit to their company. So you being here helps support them, spread the word of .NET security and .NET programming excellence. And I appreciate you being here for this talk. If you have questions for me, I am jim@manicode.com. Again, JIM@manicode.com. I'm always happy to answer your questions. If you have any questions about application security, and again, thank you for being here. Thank you for being at this virtual conference. Stay safe, stay healthy, and use this time at home to do something creative, useful, and scientific to benefit the world and benefit yourself and your family in some way. So thanks again. I'll see you next talk. I'm done. Have a great day, everybody.